Thank you. It's a pleasure to be here with you. It's great to be here, and especially to know that you're doing Shakeout, and this is a Shakeout event. So when is Shakeout? 17th, October the 17th. So at 10:17, on 10:17, everybody to drop, cover, and hold on. Shakeout is an opportunity. It was created as an opportunity for everybody to practice their drill. If it's to drop, cover, and hold on, check your supplies, see what you don't have. If you do a drill, and I'm sure you've done drills, and you've been told that if you do a drill and everything was perfect, you did it wrong. So when you do a drill, you need to find things that you have weaknesses for. And that's what Shakeout is for. Sociologists told us to be able to get people in California to do preparedness, we need to do it as a group. If people do it together, they're more likely to get something accomplished. And so with the drill, it's practice, practice, practice. The more you practice your drop, cover, and hold on, the more your body's going to know what to do. When there is a disaster, your mind goes blank. If the ground was to shake right now, what would you do? You're going to get underneath the desk. You're going to hang on to it, because with energy in the room, you're first of all going to drop to the ground, because with an earthquake, there's energy. That energy will throw you off your feet. So you want to immediately drop to the ground, crawl and get underneath something that's going to protect you from falling objects. Hold on to that object, because it will walk away from you, and then you wait for the shaking to stop. Do you go into a doorway? No. Old school, 1857, we had the largest earthquake in Southern California. It was a magnitude 7.9. How many people here remember that earthquake? Nobody? Okay. We'll talk about it in a minute. Anyway, houses fell down. Doorway was still standing, so they thought that was the safest place to go. So unless you have an adobe house that was built in 1857, we do not want you to go into the doorway, because what do we have on the doorways now? We have doors. Those doors are going to be slamming, open and shut, open and shut. You do not want to be in a doorway. You're going to be hit by the doors. Also, you're not going to be able to stand up, and you're going to be hit by everything flying around in the room. So do not stand in a doorway. Do not run outside. People tend to run. Where are you running to? It's shaking everywhere. So where are you really going to run to? You want to drop to the ground immediately. The more you practice drop, cover, and hold on, the more your body knows what to do. You don't even have to think about it. Your body automatically will do it. And so that's why we created the Great California Shakeout, for everybody to have an opportunity to drill their plan, both at work and their plan at home. So we hope that all of you are registered. I know that you are registered as an organization to doing drop, cover, hold on. You can also register individually that you are doing it at home, checking your supplies, checking your plan with your family, and some of the other things we're going to go through today. So one of the things that Matthew wanted me to talk about were some of the myths. So that's what we're going to start with first. So some of the myths are, first of all, earthquake weather. How many people remember earthquake weather? Okay, there is no such thing, all right? Earthquakes start deep in the ground. They're not affected by weather at all. You might remember the Whittier earthquake in 1987. It was very balmy the night before, and so people think that when it's balmy and warm that that's going to be earthquake weather. There is no correlation between that night, because how many balmy nights have you had that there was no earthquake that followed it? Earthquakes start deep in the ground. They're not affected, doesn't affect the weather. It also doesn't affect the animals. So ants crawling up the wall 2 weeks before an earthquake was not an indication that an earthquake was coming. It is not a prediction. Your animals may feel small earthquakes that you're not feeling, because their paws are closer to the ground. And if that event, if that rupture is on the surface, they may feel that. And there may be a small earthquake that precedes a larger one, but it is not a prediction of what's going to come, because that isn't all the time. So there is no such thing as earthquake weather. Another myth is that, oh, it's never going to happen to me. I've lived here all my life. I've been through earthquakes. I have my pantry full of canned goods. I can make it through the next one. It's not going to happen to me. I don't need to do anything. And so what we want to do is change that mindset. How many people here have experienced a 7.8 earthquake? Okay, none of you. Unless you come from another country, you probably haven't, or you're over 150 years old. You have not experienced that. You don't know what it's going to be like the next one. Okay? Northridge was a moderate-sized earthquake. It was not a big event. and we'll talk about that in a minute. Another myth is that the scientists actually can predict earthquakes. They're just not telling us when it's going to happen because it'll affect the economy. We don't know when an earthquake is going to happen. Scientists have given up thinking that they can predict earthquakes. Earthquakes are an exact time, an exact place. It's not a 6-month window. It's not a 1,000-mile radius. It's an exact time and exact place. Every earthquake is different. We don't know what stress builds up. We don't know how much stress it's going to take before that ground ruptures. And so we do not do predictions. What we do is probabilities. And I will talk about that also. So those are some of the myths, and if you have other ones, then bring them up and we'll talk about those as well. So besides earthquake, California is a multi-hazard state. We're not just earthquakes. We do live in earthquake country because of the seismicity, and we'll talk about that during this presentation. But we are a multi-hazard state. We have landslides, we have windstorms as we saw a year and a half ago, we have fires, we have debris flows and floods, we have tsunamis, and when we have an earthquake, we will have secondary effects. That earthquake will create fires, debris flows, tsunamis, and landslides. If you are prepared for one disaster, you're going to be prepared for the rest. In a fire, you're going to respond a little bit different. You're going to evacuate that building. In an earthquake, you're going to drop cover and hold on. Otherwise, your survivability is going to be the same. So how you prepare yourself is going to be the same for all disasters. And that's whether you live here in California, or you move back east, or you move to another country. Worldwide, there are disasters. You always need to be prepared, and you need to know your risk wherever you travel and wherever you live. So, little earthquake 101. I like to talk about earthquakes first of all because I think that people, if they understand what's happening when the ground shakes, you don't panic. Earthquakes have never killed anybody. How many people believe that? Okay. Well, it's not the earthquake that kills. It is the buildings that fall down. It is people that panic because they didn't know what to do. And so they run out of those buildings and get hit by falling objects. They stand in doorways. They get into elevators. They go down stairwells and they get hurt. Buildings then fall down. That is what does the damage. If you're out in the middle of a football field, you drop to the ground and you'll probably be just fine. Nothing around you to fall on you. So I like people to know what's happening with earthquakes because then you understand it and you tolerate it and you don't panic when we have one. So a little earthquake 101, plate tectonics. Our Earth is comprised of heat inside of the Earth. That heat propagates to the surface. On top of the surface of the Earth are our plates, and the heat that's propagated to the surface moves those plates around. Over millions of years, we used to be one mass of land. And over millions of years, because of this movement to the plates, our continents that sit on top of those plates have moved also. So we are constantly in motion. If we did not have this process, we'd be a dead planet. And scientists think that that's what happened to Mars, that heat died out. They didn't have that movement that created the oxygen that created what we have. So we actually need to have those earthquakes to tell us that we're still moving. So over billions of years, this is what's happened, and of course that's where our continents are today, and we continue to move. Most of our earthquakes occur around the plate boundaries. Where these tectonic plates come together is where most of the stress is. So you've got these plates that are pushing against one another. So it's like putting your fingers together, they push, and pretty soon they break. Earthquakes is the movement of rocks away from one another. And so most of our earthquakes are going to occur along these plate boundaries where these plates come together and where that stress is building up. And of course, we sit on one of those plate boundaries. An example, Haiti earthquake that happened a few years ago. This was a shallow earthquake, occurred along this plate boundary. It was very close to the surface, so there was a lot of shaking. They also don't know how to build in Haiti, so everything fell down. They're still trying to recover from that earthquake. In comparison, Chile, a couple of months later, and there was no correlation between these two events, a magnitude 8.8 earthquake versus the 7.0 that was in Chile, but very little damage here in Chile. Why? First of all, they don't have natural gas, so they didn't have gas mains breaking, they didn't have fires. They also do preparedness. They also retrofit their buildings, so very little building damage from that event. 250 people, however, were killed who were visitors to a campground because of the tsunami. They didn't know what to do. They were visitors, they didn't go to higher ground, and they were killed because of that tsunami. This event happened offshore, and it was very deep in the ground. So by the time the energy traveled to the surface, then traveled to land, it lost some of its energy. So you didn't have as much shaking as you did over here, but also because of the preparedness, there was very little damage to Chile. This is also a very small earthquake for them. The largest earthquake ever recorded in modern times, since we've had instruments in the ground and we've recorded earthquakes, which has been about 110 years. The largest earthquake was in 1960, was a magnitude 9.5 earthquake, and that was in Chile. So this 8.8 that they had was actually relatively kind of small for them. Large for us, small for them. So many of you remember the earthquake that occurred on Easter Sunday about 3 years ago in Baja, California. This was a very good example, first of all, of how earthquakes can trigger one another. This earthquake started on one fault. It traveled the distance of that fault and then jumped over to another fault and continued to rupture, creating that 7.2 earthquake. If it had stopped on this one fault, we probably would not have felt it here in the United States, but because of that, it did create this 7.2 earthquake. So this is a good example of how earthquakes can trigger one another. It's also a very good example of our complex seismic area here in not just California, but also on the Pacific Northwest, which includes Baja as well. And so we had a lot of damage, of course, to our Imperial Valley. And very few people realize that we had over $100 million damage from this earthquake in our Imperial Valley. 3,000 people were without jobs because the buildings that were damaged were red tagged. They didn't have a plan within their business to go elsewhere so people could stay employed. So people were without jobs for several weeks until they could relocate back into that structure. And that structure was repaired, or they found another place to carry on that business. This was a very good example of why businesses have to have a plan. If they have a plan, then employees keep their jobs. The business keeps their doors open, and people don't move out of the area. So this was a very good example. Another good example from this was it took 3 weeks for water to be restored to the people's households. This was an independent event. Most of you didn't even realize this. So they had all the resources to have water trucked in, but it still took 3 weeks to have water restored back to their houses. And this is one of the lessons we need to learn. We have to be self-sufficient, and water is one of the key resources. With the Japan earthquake, this was a rare event. And we have to be prepared for rare events. It's not always going to be the 5.2 that we had in Chino. It's not going to be the 6.7 that we had in Northridge. It's going to be rare events that we don't expect that happen every 500 years or every 1,000 years. And so we have to be prepared for those as well. With the Japan earthquake, Japan sits on 3 plates. And so this was a very large event that occurred out in the ocean. It was not the earthquake that did the damage, however. Very little damage from the earthquake. They survived that very well. They build their buildings so they don't fall down. People are well prepared. They have a means of communication. They have early warning that alerted them that this earthquake was coming and get into a safe place. But it was a tsunami that did the damage. And so that tsunami was much bigger than anticipated. It went in further than they expected from prior events that they've had. And of course, people were not prepared for that event. But we have to be prepared for rare events as well. There was over $48 million damage to our coastline from the Tohoku, Japan earthquake. And so a lot of people don't realize that, and that was from the tsunami. So from the tsunami, it was created in Japan. It took 8 hours for it to hit our coastline. Tsunami alerts went out for Crescent City, for San Francisco, and it took 8 hours for it to hit. It was during low tide, however. If that event had happened 8 hours earlier, 8 hours later, there would have been twice the damage because the waves would have been 15 feet high instead of 8 feet high. So because it was at low tide, there was only $48 million damage. But $48 million damage to Crescent City, to San Francisco, to Santa Cruz, Ventura, and Santa Catalina. We didn't have any damage from this event to our Port of LA or Long Beach or along our coastline down here, but we did have a surge of water. And so we are affected by offshore earthquakes. We don't have big faults offshore that we know about. like Japan does. But we are going to be affected by offshore earthquakes from Alaska. Alaska is capable of magnitude 9 earthquakes. We had the one from Japan. We had a tsunami when Chile occurred. So we're at jeopardy for offshore earthquakes. We're also at jeopardy for underwater landslides. So if we were to have an earthquake along the coastline, along, let's say, the Newport Inglewood Fault, which is capable of a magnitude 6.9 earthquake, then we could have an underwater landslide that could create a tsunami, creating a water surge. Water would come in about 6 feet along Marina del Rey, which is not close to you, but not all too far, and some of you may live there. So we do need to be aware of tsunamis in this area. If you are by the ocean, and where do people go on vacation? They go to the ocean. They go to Hawaii. They go to places that are by the water. Everybody needs to know what to do in the event of a tsunami. And so during an earthquake, you're going to drop, cover, hold on. If you are by the water, you're then going to head to higher ground. And if it ended up not to be a tsunami, what have you done? All you've done is gotten some exercise. So you want to be prepared wherever you are by the water. And you may not always feel the earthquake. It might be an offshore. And then you weren't alerted. You might be in a country that doesn't have a tsunami alert. We have, you've seen all the signs up and down our coastline, also air raid sirens that tell you that a tsunami is coming. So we do have now an alert system. So you want to go to higher ground. If you're not sure if you have property or you want to know these inundation, you can go to this website by California Geological Survey, who has mapped the inundation and how far that water will come in along our coastline. Also, Lucy Jones has just created a scenario of a magnitude 9 earthquake in Alaska and how it will affect our coastline. The reason being, similar to the shakeout scenario I'm going to show you, is so people can prepare ahead of time. So they know what can happen and they can be prepared for that. Another good website to go to is myhazards.calema.ca.gov. This website, you can put in your address up here, and it will tell you the risk that you have for earthquake, for fire, for flood, for liquefaction, and for tsunami. So it will tell you if you are in any of those risk areas where your house is located. Okay? So in California, we live in earthquake country because we sit on 2 plates. We have over 30 earthquakes a day. Most of those are 1s and 2s. How many have felt an earthquake today? No? Okay, well, we've already had about 5 or 6. Have you? Well, it might have its paws close to the ground.
It was just Matthew.
Well, we'll have to see if it was in this area. But we've already had about 5 today. I will predict we will have another earthquake today. Don't know where, don't know when, don't know how big, but we will have another one in California today. So looking at this map, we can see that these are some of the major events that have occurred over the last 80 years. 1933 was the Long Beach earthquake. Some of you may remember that one. This did a lot of damage to our schools. This happened at 4 o'clock in the morning, however, so thank goodness school was not in session, but it did a lot of damage to the schools. This is when people started to say, what can we do to alleviate the risk? This is when mitigation started in California, to looking to say, how can we build our schools? How can we build our buildings stronger so that we don't have this damage from earthquakes? And so mitigation started with the Long Beach earthquake to start identifying how we can reduce those losses. And we live in one of the best places in the world, probably second to Japan as far as preparedness. Our emergency responders travel all the time to any hazard worldwide to find out what they can learn, bring back here, and strengthen our system and what we're doing here. So we live in a very well-prepared area here. 1994, of course, was the Northridge earthquake. That was the last damaging earthquake, magnitudes 6.7. This was in an area that encompassed about 5 miles. So with this earthquake, people there could go out of the area, they could go stay with relatives, they could go to the ATM, they could go get gas, they could go to Burger King, and so they could resume their life even though their home was disrupted, but they could go out of the area. Support came very quickly to them. But this was a moderate-sized earthquake. This is not what we call the big one. The big one is, big earthquakes are magnitude 7.4 and above. And so this was actually a moderate-sized earthquake event. However, the last largest earthquake we've had was a magnitude 7.1 in 1999. And you probably don't remember that one either. Most people don't because it was out in the desert. It was out in the high desert on a military base and nobody really cared but the jackrabbits. So nobody really listens to that or hears about that one. The Landers earthquake that occurred prior to that, few more people paid attention to that, but then again, it was an isolated incident in the high desert. It did trigger another earthquake in Big Bear about 3 hours after that. And so that was another example of triggering earthquakes. We have on average a magnitude 5 or 6 about every 5 years. We've been in an earthquake drought for the last 20 years because of the Northridge earthquake. And coming up, January 17th is going to be the 20th anniversary of the Northridge earthquake. So we're now beginning to feel a few more larger events. So it's not unusual. That is usual for California to have magnitude 4s, magnitude 5s, and some magnitude 6s. And so we're getting back into that pattern again. We have over 300 known earthquake faults in Southern California. It's not just the San Andreas. San Andreas is about 850 miles long, going from the Salton Sea up through California and then recycles itself back into the sea. But this is our longest fault because it's a plate boundary, but it is not our only fault. We have 300 known earthquake faults in Southern California alone, another 300 or 400 up in Northern California. We don't know how many unknown faults there are. And so we get that question all the time when we say there's 300 known. People want to know how many unknown faults there are. And we don't know that. Northridge was on an unknown fault. We didn't know that fault existed until the Northridge earthquake actually happened. So because of the stress it builds up, we're constantly getting cracks in the ground. And so we have charted the bigger ones, but we don't know all the small ones. Out of the 300, about 24 of those are large enough, meaning long enough, the rupture is long enough that if it ruptures from one wall to the other, it can create a large event that would be damaging probably much more than the San Andreas under populated areas, because many of these faults are in areas that are highly populated. So we have the San Andreas, we have the Elsinore, we have the San Jacinto, we have the Rancho Cucamonga, we have the Sierra Madre, we have the Ventura, we have the Wilshire, we have the Newport Inglewood, we have the Palos Verdes, we have the Puente Hills, we have the Rose Canyon. We have many of those events can actually create very damaging earthquakes because they're underpopulated areas. So this is not to scare. We don't want you leaving the area, because every year people call and say, I'm moving to Northern California. Well, I'm not sure that's going to be any different. Or you're going to go to places that are going to have hurricanes, tornadoes. The main thing is know your disaster and know how to prepare for it, and then you will have peace of mind. So it's not to scare you, it's to make you aware of what you need to be prepared for so that you do prepare and then have that peace of mind and you can survive afterwards, because it's not about the earthquake itself, it's about the survivability afterwards, and that's what people need to think about. So the San Andreas Fault, we sit on two plates. We sit on the Pacific plate, we sit on the North American plate. Where these two plates to come together is our San Andreas Fault. We talked about earthquakes being on plate boundaries because this is the weak area. So here we have the San Andreas that runs right through the middle of California. We sit on the Pacific. Over here is the North America. When you go out Highway 10 and you go to Arizona, you're going from one plate to the other. What's happening here is the Pacific plate is moving at 2 inches a year to the north. In a few millions of years, we'll push San Francisco up out of the way. And if you go to San Francisco a lot, you're going to get there a little faster every year because you're going 2 inches less. But this also builds up the stress. So as we have this movement, our mountains get higher, and it is stretching this area to the point that pretty soon it has to break. And that's what an earthquake is. It's relieving that stress. You pull and you pull a piece of paper, and pretty soon it's going to tear. When you tear, it creates energy. Okay? So down in this area, this is actually also a continuation of that San Andreas Fault, but the dynamics change down here. So you have the fault going in short, different zigzag down here. So if it ruptures one part of that fault, it's not as much as rupturing 250 miles up here. So we live in a very highly complex seismic area. And so as this moves, the Gulf of California is going to get larger. We're not going to fall into the ocean. We're merely going to keep moving to the north. Upward here in a few millions of years, but it builds up that stress. So when you have this tear, it creates energy. That energy is what we call magnitude. Magnitude is the measurement. Scientists needed a way of measuring one earthquake against the other. They created the Richter scale. Richter scale is a mathematical equation that in layman's terms, it takes the energy created from that rupture, times the distance it travels, and then it gives a number to that. So within each unit of energy, you've got 32 times the energy. So within a 1 and a 2, it's 32 times. It's a logarithm, and it builds on itself. So as it ruptures the fault, it's gaining more and more energy. So if you have a magnitude 1, it's not going to be 1 times 2. It's going to be 32 times 32. So when you have that 7.0 earthquake versus the 8.8 earthquake, it's 500 times more energy was released. That energy is what then causes the shaking. The shaking then causes the damage. So earthquakes start deep in the ground. When you have that rupture, it will travel along the weakness of that fault, both directions, but it will mainly go in one direction. The energy that propagates to the surface right above that hypocenter is called the epicenter. So it doesn't just start in one spot, it starts in an area. And of course, then you're going to have shaking. The shaking then radiates all across the surface, around the world, and then comes back again. We don't feel it when it comes back again, but it does inside the earth. With that, you're going to have movement. So where you have that tear, where you have that rupture, you're going to have movement. This is that Landers earthquake in 1999. We had 10 feet of movement out in the desert along this roadway. We don't care now, but put a building on that. This is the San Francisco earthquake. It's not just where they ran out of lumber here and couldn't build the fence. This fence moved 30 feet. And so this is what an earthquake will do, is move the ground. This is a barn, again the San Francisco earthquake. This is a manure pile. This is a stain from that manure pile. This is how much that barn moved. So this was a good example of shift happening with this one. And so you can see how much it moves. That's just to see if you're still awake, okay? So with this one, this is a good example of why you need to retrofit your house. What is retrofitting? Retrofitting is if you are on a slab. You cannot crawl underneath your house. You want to bolt it to the foundation. So when you have shaking, your house is not going to fall off that foundation. It's going to move with the foundation. If you have a crawl space underneath, you're going to retrofit the wall. And that's called the cripple wall. And you're going to reinforce that cripple wall. So when you have shaking, the house does not fall into that void area. And so this is good examples of why we need to retrofit houses. Baja earthquake uplift of 7 feet. The earth moved upward 7 feet. When you have this rupture, the earth has to move somewhere, whether it's upward or it's horizontal or vertical. So this is 7 feet of uplift with that Baja earthquake. Again, out in the desert, so nobody really cared, but put that in the middle of Los Angeles and it's going to make a huge difference. Magnitude, we're trying to kind of get people away from thinking magnitude, but to thinking intensity. Magnitude of an earthquake is really what scientists care about. They want to know the size, how much energy was released. That's what they do their research on. That's what they study. But for you, what you care about is how much shaking am I going to feel? And that is the intensity of shaking. And that necessarily isn't the magnitude. You could have a magnitude 7.8 at the San Andreas Fault. That doesn't mean you're going to have a magnitude here in Downey. But it is the intensity of the shaking that you care about. Shaking is then going to be determined by the magnitude, so how large, how much energy was released from that event, how far you are from that original epicenter, so how far, what's the distance, the directionality of the energy, in other words, did it travel in your direction? That's going to make a difference in how much shaking you feel. Also the soils that you're in, and that's huge. So in California, we have a lot of granite. Energy travels quickly through bedrock. But we have a lot of sediment caused by the movement of the San Andreas Fault. As we have this movement of the San Andreas Fault, it breaks up all the rocks inside of the earth. That then creates sediment, which is loose soil. When we have an earthquake, that energy travels across the surface, gets trapped into that loose soil, and it continues to shake. And so the soils you're in is going to make a difference on what you're feeling. The quality of the construction of your building, also if you're on the first floor or the second floor, is going to make a difference. And how deep was that earthquake? So when you look at our statistics, we will always give you the depth of the earthquake so that you know then what you're feeling. If you look at a map, this is a map of Southern California. It actually, our colors are kind of bleached out here. But if the colors were right, this would be yellow. And so all these areas here is high amplification, and you're going to have this means it has a lot of sediment. 4 miles of sediment underneath Los Angeles Basin. So we're like a bowl of Jell-O. And so when it shakes, it continues to shake. Okay, when you take a bowl of Jell-O, you shake it, you stop shaking, what happens? The Jell-O continues to shake. So it's the same thing in Los Angeles, that energy gets trapped into these amplified areas. The lowest amplification is the blue here, and of course those are our mountain ranges. So if you're in mountain ranges, you're not going to shake quite as much. We cannot do prediction. I talked about doing probabilities. How we do that is where we know that there has been an earthquake fault, that there is a fault. We will dig down into that fault, and it's called trenching. So we dig down, we look at the layers of sediment over hundreds of years. We then can see these offsets. We talked about the offset, how the earth moves. Well, that is captured into our sediments as a record. And so we can go and we can look at these offsets. We can then date the soil, know what year it was, and we know from how much movement this was what that earthquake was, so how big it was. So from this, we know the history of earthquakes in California. We know that we have a large event about every 150 years, and we are way overdue for that. 1906, 7.8 earthquake. 1857, 7.9. This traveled 250 miles from Parkfield, California, down into Los Angeles. There was only 4,000 people living here at the time and no tall buildings. 1680, the southern portion of the San Andreas Fault was a magnitude 7.7. So we know it's not if, it is when. We will have another major earthquake. Will it be right now and we haven't felt it yet? Will it be tomorrow? Will it be the next day? Will it be the next year? We don't know. But people need to be prepared. We are overdue for this sized event, and we will have it again. So with the new technology at Caltech and USGS, and using some of our Shake Maps, Shake Map is one of our tools that we send to all of our emergency responders. You can use it in your Office of Emergency Management. Within 2 minutes after the earthquake, first of all, we will tell you immediately within near real time exactly where that earthquake occurred and where the location was, what the magnitude is, what the depth is, and then within 2 minutes we will send you a map that shows you the intensity of shaking. So based on the energy that went through the surface and the geology of the area, we can then tell you where the heavy shaking was. So this was Northridge earthquake. Oh, sorry, this is a scenario I'm going to show you of what can happen when we have a 7.8 earthquake. And so with our Shake Map, utilizing that, we then reconstructed the Fort Tejon 1857 earthquake. We then created a scenario to then be able to show people what they need to be prepared for. We then sat down with all of our experts from our lifelines to tell us how does that translate for you and me. When we ran this scenario, we could then see that we're looking at up to 2 minutes of shaking in many areas of Southern California. Northridge shook for 14 seconds. 2 minutes of shaking is going to be huge. You might ask, what is the largest amount shaking? And I think the Chile earthquake was 5 minutes of shaking with that one. So shaking, again, is what does the damage. From this scenario, we could see that we're looking up to 2 minutes of shaking. So what we wanted to do is we wanted to take this scenario, we wanted to share it with the public and with all of our emergency services to then be prepared ahead of time. To not have it happen and say, if we had only known, we could have been prepared better. To prepare now, to know what can happen, and then to prepare now. So I'm going to run this scenario for you. So this is in real time. So rupture has started. It's like unzipping a zipper. If it stopped right now, it'd probably only be a magnitude 4 or 5. We haven't felt it in LA yet. Our instruments are telling us this is happening. It's like unzipping that zipper. It continues to rupture the fault, 180 miles, creating that magnitude 7.8 earthquake. So here we're at a minute, still shaking in Palm Springs. It's just coming into Los Angeles. The rupture actually is stopping now, not creating any more energy, but the energy it did create is being trapped into these sediment areas. And so you will see that it will continue to shake for up to 2 minutes. And again, this yellow is the high intensity of shaking, this yellow. So we still have high intensity here. And this will continue to shake for 2 minutes. Now we built this scenario on the southern portion of the San Andreas Fault because there's an 89% probability that's where the next earthquake will be. Could be on the San Jacinto, could be on the Elsinore. Some scientists think it might be there rather than the San Andreas. But 89, or actually 59% probability that's where the next one will be, is in Southern California. So I'm going to show you another view of this, which actually shows you a little bit more how earthquakes happen. And these are great tools that I've given to Matthew that he can use for students to teach about earthquakes as well. So the earthquake starts here. The different colors are consistent with our shake map. These colors are showing you exactly what people are feeling, all the way up to hardly felt, all the way up to heavy damage. So this rupture has started, and of course the first wave that you feel is going to be the P wave. That's the preliminary wave. With a large event, sometimes you hear it coming. It sounds like a train coming, and it's actually the ground moving that you're hearing. And so here we have the P wave that's coming through now. We're just coming up here. So here's the P wave coming through. The P wave travels at 3.2 miles per second. The S wave follows that, travels at 2 miles per second. It's a little bit slower because the S wave has the heavy shaking. And so when you've experienced an earthquake, the shaking will get stronger, 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 because then your S wave is coming through. And so now we see the S wave coming through, and this again will carry your heavy shaking. So right now we're shaking. Everybody is drop covered and held on, and so things are falling off of shelves, loud noises, but now comes the S wave, and the S wave is your vertical, your horizontal, your Rayleigh waves, and your Love waves. And so you have all these waves that are coming through now, creating more damage, and they will be stronger. So you can see how the colors are changing because now this is high intensity of shaking. And you can see this is throughout Southern California. This is an event that will affect 8 counties of Southern California. Not Northridge, we can go 5 miles out of the area and life is normal. This will affect 8 counties of Southern California. And you can see all the heavy shaking. This is all heavy shaking. Here, this is a good example of what we talked about with the soils. So where this is dividing, this is a mountain range. So you're not having that heavy shaking here because that's a mountain range and the waves are going quickly through there. So we're pretty much, let's see, where is Downey? Downey's going to be down, what, around here? Yeah, so you're pretty much toast with this event. Okay. Now, that doesn't mean you're toast. That doesn't mean the building's falling down. You have drop covered and held on. But what you're going to have to do is be aware that this surrounding area was heavily hit. So are you prepared for that? Okay, and we're going to talk, that's what we're going to talk about now, is what you're going to do before this event happens. So we sat down with all of our experts to tell us exactly how this was going to affect their infrastructure. How is it going to affect the water, the power, the gas, our roadways, our sociologists, our economy. And we sat down with 300 experts to tell us how we were going to be affected from this. So from this, we know that this will affect over 300,000 buildings throughout Southern California. We have many buildings that are pre-1970s building codes. We have many buildings in Los Angeles that are non-retrofitted. A lot of buildings in Riverside and San Bernardino that are non-retrofitted. We have bridges and overpasses that are not retrofitted. Caltrans has spent $16 billion retrofitting their bridges and overpasses. They look to be okay in this scenario, but hundreds of thousands that are owned by cities and counties that will not fare well. So we're looking at widespread damage to all of our lifelines, to $213 billion in damages. So they're again working with insurance companies to make sure they don't go broke like they did with the Northridge earthquake, because we're telling them this is what's going to be the damage and you better be prepared for it. 270,000 people being displaced for long periods of time, 50,000 injuries requiring hospitalization, and our hospitals will be affected. 1,800 deaths. We've not had an earthquake here with 22 million people, so this is a guesstimate coming out of UCLA. Based on earthquakes in other areas that are similar to ours. If this is in a different location, then these numbers could be a lot higher because obviously San Andreas Fault has a lot of unpopulated areas. Newport Inglewood does not, or the Puente Hills. Many of our lifelines go through the Cajon Pass, and so does the San Andreas Fault. So they're all going to be affected by this. Our roads, Highway 10, Highway 15 are going to be heavily affected by landslides because they cross the San Andreas Fault. And so they are going to be down, and with continued aftershocks, even though they get them repaired, they're going to be damaged again. Highway 5 with this scenario looks to be okay. That's where our mutual aid will come from, is from Highway 5. Water is key. We know that our pipes are over 100 years old. We're going to have 2 minutes of shaking. They're all going to be broken. Our water companies have told us it will take 18 months for full restoration of water to your households. So people have to have water. You can live without food. You cannot live without water. After 3 days, you're not here anymore. So you have to have water. If you have water, store more, at least 3 to 4 weeks. So 1 gallon per person per day for at least 3 to 4 weeks, 7 to 10 days if maybe you're going to a shelter, but it's going to take time for those shelters to be set up. So you have to have water in the meantime. Utilities, electricity will be out. Electricity may go out, and that's our early warning because there's substations out along the San Andreas Fault that will go out. So electrical power will be out. Full restoration, again, 18 months. Some will be within weeks, some will be within months, but full restoration, 18 months. You need to have a backup plan. Businesses need to have a backup plan so you can come back to work. You need to have a plan at home so you're not in the dark for that length of time. So you need to have generators. You need to have a backup supply. If you have people in your home that require medical assistance, you need to have a backup plan for that. Phones will be totally overwhelmed. You will not be able to use your cell phones. Chino earthquake, all the cell phones were out, and that was a magnitude 5.4 earthquake. You will not be able to use the cell phones. They have no earthquake requirements for their towers. And even the airwaves will be jammed. All those airwaves will be jammed with emergency response. You might be able to text. That's a smaller broadband. But then what happens after your phone goes dead because you couldn't charge it because no electricity. So you need to have a plan to charge your cell phones. Gas, keep your landlines because emergency service will come back to your landlines first. Gas will be out. If you smell gas, turn it off. If you don't smell gas, don't turn it off. It'll be months before the gas company turns it back on for you. If you don't know, go home now, look at your meter, see how the wheels are turning, and then when you go and look at it and they're spinning, you know that you're losing gas somewhere. So know somebody in your neighborhood that can turn it off for you if you can't get home. But gas will be a huge issue. We're looking at 1,600 ignitions of fires with this event. That's going to be from broken gas mains and down arcing wires. So fires are going to be huge. FEMA already has a catastrophic plan for this event, but fires are going to be huge. We don't have enough manpower and we aren't going to have enough water, and they already know that. So it's going to be huge. We don't expect you to put out a conflagration, but what you can do is know how to use a fire extinguisher so you can put out a small fire before it becomes a large one. And so that's where you will come in, is knowing how to use that fire extinguisher. We already talked about buildings. Transportation will be huge. Roads will be broken. Bridges will be down. Debris on the roadways from falling objects. Cars will be abandoned. You may have to abandon your car. You need to have supplies in your car. You may have to walk for 15, 20, 30 miles. You want to have shoes in your car, a flashlight in your car, water in your car. You need to have a first aid kit. You want to have a whistle. Because if you can't get the doors open, you can blow that whistle a lot longer than you can yell for help. And you want to have a whistle in your house in different rooms, because if the doors get jammed in the bathroom and you can't get out, you want to be blowing that whistle so that people know that you're in there. So you can have a whistle. So know that roads will be down. Also know that because of this, you may not be able to get home. How many people live outside of 10 miles? Okay, you may not be able to get home and you might have to shelter in place. So have supplies at work. Have them in your car so that way you have supplies at work as well. That's why you need to have a plan within your family, because if you're stuck at work, you've already gone through the plan. They know what the plan is. They're not going to be nervous because they know you're stuck at work and you may not be able to get home for 2 or 3 days. No communication, so you're not going to be able to communicate with people. Okay? So you need to have supplies in your car. What you need to have also is an emergency contact plan, so that you contact one person instead of 30 people in your family. You contact one person that's out of the area. So every family needs an emergency contact in Arizona, San Francisco, New York, that everybody in your family calls that one person to find out how everybody else is and check in. How many people keep all their contact information in their cell phone? Okay, cell phone dead, can't get to it. So you want to make sure you write it down and put it. I keep it inside the cover of my cell phone, and I keep it written down. If you can find a ham radio, any ham radio operators? Okay, identify those. Somebody may want to do that, because then everybody here can go to that ham radio operator, communicate through them. They can send messages to your emergency contact through a ham radio operator. Let's see. So we need to know that this together we can prevent the disaster from becoming a catastrophe. It's not if, it is when. What you do now before that earthquake is going to make a difference in your life afterwards. If you have enough water, you're going to not be thirsty. If you have a plan with your family, you're going to have peace of mind because you know that they know what to do and you have drilled that plan. So we need to know, number one, that emergency responders are not going to be there for us. We have to be self-sufficient. We have to be able to be on our own for at least 3 to 5 to 7 to 10 days until emergency responders can get into the area to help us. Everybody has to be self-sufficient. That fire truck going down the street is not going to stop for you. They are surveying the area to report the damage so that they can work with the bigger problems. So everybody has to be self-sufficient. So what you need to prepare ahead is about survivability and then recovering afterwards. Secure your space. Anything that can fall down will fall down. Your big screen televisions, 22 million people in Southern California. How long is it going to take to replace that if it fell down and broke? And so Super Bowl will not be there for you next year if you have not secured your big screen television. And hopefully you get electricity, but then you've got the generator so you can watch that Super Bowl. Secure your stuff. So anything that is tall, over 6 feet tall, you want to secure it. Any heavy objects you put on the bottom shelves, so if they fall, they're only going to fall to the ground. They're not going to fall on you. You want to secure appliances. In Northridge earthquake, they went out the wall, all the way out the wall because you have the energy behind that that's pushing it. So you want to secure any appliances that are not built in. Also, you don't want them breaking away from the gas line. You want a flexible gas line, but you don't want it breaking away and causing a fire. So have an evacuation within your family. Part of your plan is to create an evacuation and meeting place. So after the earthquake, first of all, you take care of yourself. Do not go running to your children. Northridge earthquake, people went running down the hallways, were slammed against the hallways, broken arms, broken legs, broken collarbones. By the time they got to their children, they were already injured. The kids were fine, they slept through it. So you want to take care of yourself first, have a plan so you know your children know what to do, that they are going to stay in bed. If the earthquake happens and you're in bed, you stay in bed. So you removed everything around you that's going to fall on you. Your television is on the dresser. It's not going to end up in bed with you. You're going to pull the covers up over your head. You're going to lay down on the bed. You're going to wait for the shaking to stop. Do not get down next to the bed. Beds will go up in the air, come down on you. Underneath the bed, though, you need to have shoes. Why? Because after the shaking stops, what's the first thing you do? You jump out of bed and you're walking on glass. So you want to have shoes under the bed, flashlight in your shoes, so you're looking for objects that are now fallen over, you're not tripping over them, and you're not walking on glass. Have an out-of-state contact, know where your emergency supplies are, so you want to have a kit in your car, you want to go have a to-go bag in case you have to evacuate quickly. And you want to have your big supplies, not in the house, but probably someplace outside. You can have them in various places if you want to. Don't keep your water supply with your food supply, because if it starts to leak or breaks, you don't want to damage the rest of your supplies. Keep copies of all your important documents, because you may just get out and you may not have anything. So you need to have copies of your driver's license, copy of your birth certificate, banking information. If you don't have a place to store it, put it in your emergency pack. You can also send it to your emergency contact person if you trust them. And so then they have a copy of your important documents as well. Contact numbers that you need to call in a disaster, call your utilities, have them turned off. If you're not going to be home, you don't want to be paying for the bill. So you want to make sure you tell them that you're not at home anymore. Same thing with your credit card companies. Tell them there's been a disaster, you're involved in that, so that you don't have to, that you're not charged fees for that if you don't make the payments right away. Work in neighborhoods, you're only as prepared as your next door neighbor. You might be able to survive for 3 months, you have camping supplies, you're just fine, but if your neighbors have nothing, they're going to come to you. And you're a nice neighbor, so you're going to share. Now, all of a sudden, you only have 2 weeks of supplies instead of 3 months of supplies. So work in neighborhoods. It's called Map Your Neighborhood. It is a system devised by Washington State, and we're doing that throughout California, of Map Your Neighborhood, where neighbors work together to identify their risks. They have volunteers that then somebody can feed your animals if you're stuck at work. Somebody can turn off your gas if you're stuck at work. They go through, they check the households that are designated, and then they all meet at one place and they work together. And that's with any disaster, not just an earthquake, but with all disasters. Drinking water, you can store it in 55, 35-gallon drums that'll keep for 5 years. You dump it out, you can refill it again. You can do that 3 times, so up to 15 years you can store water. You can store it in bottles, but make sure you recycle them because they will disintegrate. If you store them on cement, there's a chemical reaction, they'll disintegrate faster. So you want to have a buffer, either a rug or cardboard or something between those bottles. In your car, you want to use these kind of packets that are silver packets because they can go from hot to cold, hot to cold. And so you want to have those, but there's not a lot of water in them, so you want to have either the bottles or the containers for your regular supply. These are things to put into your car kit to carry with you, and this is good even if you travel and you're going up Highway 5 and you get stuck in a snowstorm. You've got supplies in your car. These are things that you can put in your big emergency kit at home, and basically it's everything you use on a regular basis, from your makeup to your medications to an extra pair of eyeglasses, to your car keys because you may not be able to find them, to your emergency documents, rope because you're going to be tying up things, heavy gloves. Always have heavy gloves both in your car and under your bed because you're going to be moving things that are sharp and debris. The shoes need to be heavy shoes because you're going to be walking in debris. Always keep your gas tank half full because you can charge your cell phone, you can listen to the radio, and you can be in your car and keep warm or cold. So always have the gas tank half full. You also have to want to have cash, $1 bills, $5 bills, $10 bills, because no electricity, nobody can make change. So you go to buy something and it might cost you it might be a $2 item, but it's going to cost you 20 bucks because that's all you have. So keep cash on hand, and I have one person tells me she buries it in the backyard because she didn't want the burglars to get her emergency to-go bag. So she puts her emergency contact and all that information and buries it in 3 baggies in the backyard so she can get to it. Drop cover, hold on. This is what you do. So beforehand you're going to prepare, and preparedness is a process. It is something, not something you go out and do tomorrow. It's something that you do over time. You start today. You already have 32 gallons of water in your water heater. If you don't have a tankless, you have 32 gallons of water already. So you've already done something. So you want to start today. Go to Target, get a bin that costs, $8, $10. Start filling it up with the things that you're going to need to have during a disaster. It's a process. But during the earthquake, you want to know how to protect yourself. Drop cover, hold on. So we already talked about that. This is why you do it. This is the Haiti earthquake. The school building fell down. The desks are still standing. So getting underneath something, you are more apt to survive being underneath something that will protect you from falling objects. This is the Baja earthquake. Desks are still standing. The books haven't even moved, but look at the non-structural. Non-structural is not covered by code. We don't want you to be injured by the non-structural. Buildings in California are much safer than they used to be. We don't expect a lot of those to fall down. The 300,000, yes, but know your building. Know what it's going to do. But chances are this building is probably going to be safe. You want to protect yourself from falling objects. Always know the building you're in and what you're going to do. So if you're in bed, stay in bed. If you're outdoors, move to a clear area. Drop cover, hold on. If you're in your car, pull over to the side of the road, set your parking brake, lay down on the front seat. Hopefully you're not under a bridge or overpass, but don't go driving around. The more movement you make, the more you are apt to get hurt in an earthquake. So you want to immediately drop to the ground and protect yourself immediately. We talked about gas valves. So we created the Great California Shakeout as an opportunity to drill your plan, as an opportunity for you to start your preparedness, to have that plan within your family. So number 1 is water. Secure your space, have the plan within your family, drill that plan. And then with a neighborhood, be CERT trained. People that are CERT trained, that's a community emergency response training. It's free. It's through the fire department. It was just LA County. Now all the cities are doing CERT. You can go find out when their next class is and be trained. They train you in fire suppression, first aid, incident command center, and triage, medical. Okay, so that you are prepared. At least one person in every neighborhood should be CERT trained. You can go to our website at shakeout.org, register your participation. As of today, I believe that we had, was it 11.5 million people in Southern California, 21.9 people worldwide. We are not just California anymore. It is now being done in 8 different countries. And so it is now global. So go and register. You can also find out information on how to be prepared. There's also things that you could hand out to your neighbors, hand out within your organizations on information on how to be prepared.